Six of us are students at the University of California at Davis. We are studying plant sciences because food production is one of the most important things humans do. The objective of this video is to provide information about different farming systems so that you can make an educated decision about what farming system is right for you. In our class, we've learned that successful farmers pay attention to balancing the 3 E's: economics, equipment, and ecology. Different styles of agriculture use various methods to prepare the soil for planting, and this is called tillage. We'll contrast the two extreme ends of the tillage spectrum: conventional and no-till. Conventional tillage uses heavy equipment and intensive use of machinery, whereas no-till doesn't disturb the soil at all before planting. We will look more in depth at these two styles and then frame them into the 3 E's framework.
Our plant science course on vegetable production allowed us the opportunity to experiment with broccoli under 4 different farming methods. We transplanted Avenger hybrid broccoli sprouts in 4 different plots with identical irrigation, nutrient management, and climate conditions. We applied a different tillage regimen to each plot. Tillage refers to the way farmers prepare the soil before planting. Our goal was to investigate how broccoli yield is affected by different tillage systems. While we tested out 4 different tillage methods, we think that systems 1 and 4 are most useful as starting points for a small farm or garden. System 1 is similar to most large-scale conventional farming operations. It is the most intensely tilled system and employs 6 different tractor implements. System 4 is a no-till system that minimally disturbs the soil. It only required 2 implements and 2 passes with a tractor, one with a roller and one with a transplanter.
Now that we've covered the basic differences in the field preparation activities between systems 1 and 4, we can examine each system within the framework of the 3 E's to help you determine which system is the best fit for your needs. So let's take a look at the different equipment we used in this planting system. We planted a summer mixed cover crop before the broccoli, so the first thing we have to do is deal with the cover crop before we transplant the broccoli into the fields. In system 4, our minimum till system, we used a roller just to knock over the cover crop and then transplanted basically through the knocked over plant residue from the cover crop. So in planting system 1, our conventional tillage system, first we used a shredder to break up all of the remaining cover crop residue, and then a disker to help incorporate it into the soil. After that, we used a tool called a ripper to break up big soil clods, and then a lister to form some furrows, which will help us create our bed paths. The final tillage equipment was called a bed shaper, which helped create nice, even, flat, straight beds, which we could transplant the broccoli into. So we're lucky because we have a deep well right next to our broccoli fields, but this is how we've irrigated our plantings. So this generator pumps water directly from our well and then routes the water through this system here, which consists of a pressure gauge, a filter to take out any sediment in the water, and then it also runs through this fertilizer system, which pumps some liquid nitrogen into the water system. The water and sometimes the fertilizer also then comes through this main hose here, which feeds into the smaller drip lines, which we've laid really close to the broccoli plants so that the water is immediately available to the broccoli roots. So to measure soil water, we use this rig called a tensiometer, which is a probe like this that you can stick into the soil. And basically it measures the content of water in any given amount of soil, or about how difficult it is for a plant to suck water out of the soil and for it to enter the atmosphere. And this is our rain gauge we use to measure precipitation. Basically, it's a bucket with a funnel on the top, and as rain falls, it's measured on this gauge right here. We use this evapotranspiration gauge to measure the amount of water that moves from the soil through the plants and up into the atmosphere. So by using our soil tensiometer, the precipitation gauge, and the evapotranspiration gauge, we can get a pretty good sense for how water is moving through our planting system, and also figure out how and when to turn on our irrigation system so that we can be really conservative about water use, which is a critical aspect of efficient agriculture.
Now let's take a look at the second E of farming, economics. The low tillage system requires less upfront costs in pre-planting equipment, time, labor, and energy. The conventional system requires significant upfront costs in equipment, time, labor, and energy. The cost of each tractor implement ranges from a few $1,000s to $300,000.
There are trade-offs in the amount of pre-planting costs and subsequent costs in terms of irrigation, labor, plant vitality, and field productivity. Field preparation in each system dictates the types of irrigation systems that can be implemented. We use drip irrigation in both systems, but furrow irrigation is another irrigation option employed by many farmers. Furrow irrigation is not an option in System 4 because there are no furrows. Drip irrigation costs approximately $1,000 in materials per acre to install, plus the cost of labor to install and maintain. Furrows require time and tractor equipment to create, but the continued costs of use are relatively low. Conventional wisdom holds that the increased upfront costs will be recuperated through increased profit through productivity gains, but the data we collected does not reflect this theory. This graph shows the trajectory of growth over the course of the experiment. We collected above-ground biomass samples from each system once a week to track crop growth. We did not find a significant difference in above-ground biomass between the four systems. As you can see on the graph, there was only a 12% difference between System 1 and System 4 average biomass.
We also measured the plant's root-to-shoot ratio, which is a common indicator of plant health. Ratios closer to 1 indicate higher levels of plant health. As you can see from the graph, System 4, our no-till system, had the highest root-to-shoot ratio.
The final consideration for starting a farm is ecology within the agricultural system. Managing the ecological impacts of your crops is an important step to achieving balance and for improving the overall outcome of your crops. Crops don't naturally grow the way that we plant them in rows, so we have to feed them nutrients and keep them safe from pests. In addition, cropping is really hard on the soil, so we have to take into consideration the amount of nutrients that are coming out of the soil, as well as the effects of tillage on the soil.
To understand the ecology of our system, we measured the presence of a common detrimental pest known as leaf miners on our broccoli plants in week 9 of the experiment. We found that on average, broccoli plants in the no-till and low-till systems had twice the number of leaves damaged by leaf miners than the two conventionally tilled systems.
In the conventional system, many tillage implements were used. This puts a lot of stress on the soil and causes issues like soil compaction, loss of soil organisms, reduces soil cover, reduces water infiltration, and in addition, it leads to soil erosion. This is a major contributing factor to the loss of organic matter in the soil. In the no-till system, by reducing the number of implements we used, we left more residue from the previous crops. This helped retain soil moisture and reduce runoff. By leaving some root systems intact, it helped to combat water and wind erosion. By reducing the number of passes over the field, we helped to fight soil compaction and increase water filtration. Leaving crop residues on the field is obviously important, but in a conventional system, the field is likely left fallow without anything planted between crops. So, cover cropping is another important tool in a farmer's toolbox.
We hope that this video has provided you with a useful framework and valuable information to begin your career in farming.